So, section 10.3 is a little bit more challenging. It starts out really, really easy because it's basically one of the easiest ways that you can display data. So, like for instance, most of you know how to do this. If we polled kids who are attending a school concert and we only asked freshmen and sophomores. So let's say we talked about the freshmen and we talked about the sophomores. And they could either attend or they could not attend, right? There's really two things they can do. Let's say that 25 freshmen are going, 44 freshmen are not going, 80 sophomores are going, and 32 are not going. This is pretty much one of the easiest things that we can do. This is how this starts out. So this is how this entire two-way table starts out. Now, a couple different things that we can do with this is we can actually start to calculate probabilities. Now, they may make this a little bit more challenging than it needs to be, but we have to go through it. So we can go through and we can total these things up. So 25 and 80 means that 105 total are going. It means that 76 are not going, right? Which gives us a total of 181 responses. I could say that 25 and 44 are total. That's total freshmen. And then 80 and 32 is going to give me 112. And again, that adds up to 181. Both of those two things should add up to the exact same thing because we pulled the same number of people. These numbers on the outside that we just totaled up, these things right here are the marginal frequencies. Those are totals. Marginal frequencies are when we add the rows together. Okay? Now, there are other types of frequencies that we can deal with. I'm not going to spend too much time talking about this concept right here because all of you can read a graph and you can talk to it or look at a table, and it's really should be no big deal. But that being said, you have to be able to understand how to read this table. If I asked you how many freshmen are going to this, you better be able to tell me that the answer is 25, right? But now let's talk about probabilities, because we're going to use these exact same numbers. So if you need those numbers, pull them up on your notes so that you have them right next to you, so that way we can talk about them right now. But right now, what we're talking about is we're talking about joint relative frequency. Now, joint relative frequency basically just puts these things in probability form for us really, really nicely and really, really quickly so that we don't have to do any more work. So we're still taking the same exact table, but now we're going to use the total that we remembered was 181. There were 181 total kids, right? So if I want to find the joint relative frequency, I take the number that I had and divide it by 181. I take the number I had and divide it by 181. Sorry if you can hear my kids yelling downstairs. I have 80 over 181, and then I have 32 over 181. Now this is basically just talking probability. If I want to find the probability that a randomly selected student is a freshman who is attending, it would be 25 over 181. So now I'm going to convert all these to decimals. So it's going to be 0.138, and these are rounded, so they're not exact, but they're pretty close. 0.243, 0.442, and then 0.177. Now again, we can go through and figure out the marginal frequencies for these things. The top part adds up to 0.381. The bottom one adds up to 0.619. Then we have 0.58, and we have 0.42. Again, when I add all these together this way and this way, I should get 1 because that's my probability of everything happening. That's what this is. This is probability. So if I go through and calculate the table this whole way, it's very easy for me to say what's the probability that a person is a freshman and attending. Then that's just, it's 13.8% because that table shows me that information right away. So that's actually really, really nice that that happens. Okay? So now we're going to step it up one notch. Okay? This thing right here is a conditional frequency. So this thing is a conditional frequency. Okay? So what this is basically saying given something. Okay? So this is saying like given something. I'm going to use the same table that I had last time. So I have freshman, sophomore, attending, and not attending. And what I just figured out was 0.138, 0.243, 0.442, and then 0.177. Now when I figured these out and I had my totals, which were 0.381, and then I had 0.619, and then I had 0.58 and 0.42. So I had these. Now, the question would ask you something along the lines of, given the student is a freshman, what is the probability that they are attending? So what we're going to do is we're going to look at, obviously, we want a freshman that's attending, right? So the freshman that's attending is going to be this number, 0.138. That's the probability that the person is a freshman and they're attending. But this is saying that given the person you picked was a freshman, that tells you that you're looking at the total number of freshmen, which is 0.381. So now we're just going to calculate that percentage. So I'm saying basically at the very beginning, I don't care about the sophomores. The sophomores don't exist. I'm only dealing with the freshmen. So it's going to be 0.138 divided by 0.381, and 0.138 divided by 0.381 is about 36.2%. So that tells me that number. Okay? Now I can also change it a little bit. Okay? So here's another example using the exact same table. Alright? So if you need that, pause it and go back. So let's say given the student is, let's say this, let's say given the student is attending, so we're now paying attention to students that are attending, what's the probability that that student was a sophomore? So now basically what we're doing is we now know that we're looking at the attendance, which is, I should erase these to make this easier to see. We're looking at the attendance more than anything. So we're looking in this column right here, and we want to know what the probability that that person is a sophomore. Okay? So, given the person is attending, we're looking at this, and they're a sophomore, so we have 0.442 over 0.58. So out of the people who are attending, how many of them were sophomores? So 0.442 divided by 0.58, and that tells me it's 76%. And if you look back at the very beginning of this table, it says 80 sophomores attended and 25 didn't. So that tells me it should be a little more than 75%. If there are 105 total people and 80 of those did that, great. Now, some of you may find other ways to do this. Totally fine. I don't have any concern at all if you choose to use a different method of solving this thing. I actually think that for some of you it's a better idea to try to find your own ideas. Okay? This is just two examples. If you have questions, make sure that you ask me about them, because some of you are going to, play around with this and you're going to realize, hey, I could just do 80 divided by 105. Is 80 divided by 105 76%? Sure. And if it is, use that. The only reason I show you this is because when the SAT rolls around, this is going to be kind of tricky. Okay? Because they might throw these numbers at you and ask you what they mean. You're just telling basically it's already a formula. It's already this. It's already this. Make sure that you're paying attention to it. Okay? If you have any questions, ask me. I'll be around. I got nothing but time. So make sure you ask me questions that don't make sense. See ya.